Okay, today we're going to talk about the normal distribution, or otherwise known as the bell curve. You might recognize it. So when we talk about a distribution like this, we're saying a widely distributed, lots of data and so on and so forth, where the mean is right in the middle here. So right there, we're going to go ahead and throw in x bar, the mean of our data. Then, remember that standard deviation that we calculated before? Well, if we take the mean and we add one standard deviation, we end up here, add another standard deviation there, and add a third one, we're going to end up there. And let's go ahead and do the same thing, but let's subtract a standard deviation, subtract another one, and subtract a third. So if I was to label this, let me go ahead and get some color here. We've got x bar there, and here we're going to say we've got the mean plus one standard deviation, the mean plus two standard deviations, and the mean plus three standard deviations. Over here, the mean minus a standard deviation, mean minus two of them, and the mean minus three standard deviations. So why is this important? The reason this is important is because we've got a thing we call the empirical rule. Okay, the empirical rule. And it's just an estimate, but it's a good estimate to work with. The empirical rule can also be known as the 68, 95, 99.7 rule. And what that's saying is that 68 is one standard deviation above and below the mean. And approximately 68% of your data will lie within that amount, within -1 and +1 standard deviations of the mean. Then, when we go over to here, we're saying that roughly 95% of the data will be within -2 and +2 standard deviations of the mean. And the last one here is, of course, 3 standard deviations of the mean. And yep, you're right, it's 99.7%. So we can tell you things like the mean is this, the standard deviation is that, and we can draw a quick normal distribution curve here to figure out approximately what percentage would be between some values. So an example for us would be something like this. Let's say we've got, gosh, I don't know. Let's say we've got a standard deviation mean, of 100 and a standard deviation of, let's just go with 10. Make it nice and easy, right? So that would mean that right here the mean is 100. And if we add one standard deviation to that, that's 110. Add two standard deviations to the mean, there's 120. And if we add 3 standard deviations, we get 130. Over here, subtracting a standard deviation, subtracting 2 standard deviations, and subtracting 3 standard deviations. Okay? So I'm going to tell you it's always a really good idea to draw this picture so you can see where those cutoffs are. So now what we could do is we could ask you about what percent is between, I don't know, let's say 90 and 110, right? Well, that would be right here, 90 to 110, that's one standard deviation in each direction. And we'd say that's approximately, right, because it's just a rule, it's a rule of thumb, approximately 68% of our data would be between those values. Now, another example kind of question could be something more like this. What percent is less than, oh gosh, let's say 110, right? So let's make the question mark there. What percent is less than 110? So we're talking about from this value here all the way down forever. So the mean right here would be what percent? How much is below and how much is above? Correct. That would be 50% to the left approximately and 50% to the right. So going that way, cut off, and going that way. So if we're talking about 110, half of this data is 50%. So we're left with figuring out what portion is this, right? So we've got 50% from here on down. What portion of it is this? Well, if this is nice and symmetrical like a normal distribution is, this would be half on each side. So half of 68 is 34. So that 50 plus that 34, let's go ahead and write it down here. 50 plus the 34, and we find we get, again, approximately 84% would be below there. Now we can go on to one last question here, and what I'm going to say is, let's say, what percent is, let's do between again, what percent is between 70 and 120? Well, that's a little bit more thoughtful question. 70 and 120 from here all the way to there. Notice this is 2 standard deviations away, and that is 3 standard deviations away. So this gets us to the point where, sure, we can say right here is 95%, but we would still need this remaining amount. So one thing that's a really smart idea to do is to know what each of these portions break into. We've already found the first one. We found that this was 34%. So over here we'd have another 34%. Now, the trick is to realize all of this, where the black line is 95%, and this is 68%. So this remaining portion is cut in half, and it's the difference between the 95 and the 68. So I'm going to go back to orange. I'm going to say 95 minus 68 is 27. What's half of 27? Well, that's 13.5, isn't it? So that's 13.5, and over here is 13.5. Now we almost know enough to do our problem. We still need this little gap, and it's a smart idea. We're going to figure out what this part is too in a moment. So same strategy. If this is 95 minus 68 to get the difference for those two, to find these, we do the same thing with the 99.7 and the 95. So let's take 99.7 and subtract 95 from it, and we get 4.7. When we cut 4.7 in half, we get 2.35. So this portion here is 2.35 and 2.35. So now we're able to do what we need for our problem down here between 70 and 120 in this case. So we know that from 80 to 120 is 95%. So I'm going to put that here, 95% approximately. We know there's an additional 2.35%. 2.35. So that brings us to an approximate solution here of 97.35. Now again, these are just approximations. We will in the next lesson figure out a way to do this more accurately, and more specifically what to do when our values are between any of these. We chose a nice easy example where the mean was 100 and the standard deviation was 10, but this can work for any mean and any standard deviation. Always a smart idea to do the drawing so that you see what's going on, so that you can then either use the empirical rule or what we're going to use next class. So I hope this helps out, folks. If you have any questions, come talk to me during video conference. I'll be there. Don't be square. Bye.